Hey kids, it's Mrs. Butcher. This actually is the last video I'm going to do for you this year. This is trigonometry with right triangles, so this is just a review for the most part. Alright, let's just start with a general right triangle. We have an angle theta. I forgot to put in theta. There it is. Theta could be either of the smaller angles, not the right angle, so I just chose this one to be the bottom one. And we always have two legs. One of them is opposite of theta, and one of them is adjacent to theta. Remember, adjacent means touching, opposite means across. And then we have the hypotenuse of the right triangle. So do you guys remember SOHCAHTOA? SOH is because sine of theta is equal to the opposite leg divided by the hypotenuse. Cosine of theta is equal to the adjacent leg over the hypotenuse, and tangent of theta is equal to the opposite leg over the adjacent leg. We also have three inverse trig functions. So the inverse of sine is going to be cosecant, and the inverse of cosine is going to be secant, and the inverse of tangent is cotangent. So now we're going to ask you for the 6 trig functions whenever we deal with right triangles. You already know SOHCAHTOA, so all you have to do is remember that the inverse of sine is cosecant, so we abbreviate that with a CSC theta, and the inverse meaning the reciprocal h over o. So the cosecant is the h over o. The secant, which is the reciprocal of cosine, secant theta is going to be h over a, and cotangent theta will be the reciprocal of tangent a over o. So here's an example. If I asked you to evaluate the 6 trig functions of theta, here's theta, we would want sine theta equals, and we know that's SOH, so opposite, which is this side, over the hypotenuse, which is this side. And if you notice, we have the opposite, but we don't have the hypotenuse. So we have to figure out the hypotenuse. And you guys hopefully all know that whenever we have a right triangle, all we have to do is go a squared plus b squared equals c squared. And 24 squared plus 7 squared, if you took the square root of that, you'd get 25. So we now know that this is 25. So our sine, O over h, is going to be 7 over 25. And if it is a fraction that you can reduce, then you need to do that. So cosine theta, cosine is a over h. This is our adjacent here. So 24 over 25. Tangent theta, and make sure when you're writing these that you write the trig function tangent, you write the variable of the angle theta, because tangent is an operation, theta is the angle that we're doing it to, and tangent theta, TOA, 7 over 24. Don't just put tangent equals, or just tangent. Put tangent theta equals 7 over 24. Then we'll do the reciprocal functions, so cosecant theta is just going to be 25 over 7. Secant theta will be 25 over 24. And cotangent theta will be 24 over 7. Okay, here's another example. If theta is an acute angle of a right triangle and cosine theta equals 3/8, what is cosecant theta? You like my little hand-drawn thetas in there? So you're just going to say, well, I know that cosine theta is the adjacent over hypotenuse. So they told us that was 3/8. That means that if I have a right triangle, 3 is my adjacent and 8 is my hypotenuse. So I'm going to just draw that. We're going to make this be a right triangle. It doesn't really matter if you draw it to scale or not. Mine's pretty bad. But pick one of the acute angles to be theta. And then we have our adjacent, our opposite, and our hypotenuse. And then we're going to say, well, the adjacent is 3. The hypotenuse is 8. So what is cosecant theta? Well, we know that cosecant is the reciprocal of sine. And sine is O over h. The reciprocal of O over h would be h over o. So that would be the hypotenuse over the opposite side here. And once again, we don't know what that is, so we just use our handy-dandy Pythagorean theorem. 3 squared plus our opposite side squared equals our hypotenuse squared. So that means I'm going to have to take 64 minus 9, and I'm going to get 55, which means x is the square root of 55. And reduce your radical if you can, but in this case we cannot, so square root of 55 is our opposite. So that means that we are going to do 8 over the square root of 55. And then, if you ever come up with a radical in the bottom of your fraction, you know what to do. You have to fix it. So we're going to multiply the top and the bottom, both, by the square root of 55. And we get 8 root 55 on top. Get a plain old 55 on bottom. That would be cosecant of theta right there. All right, the next thing we're going to talk about is our special right triangles. And these are the ones that we're going to really get into working a lot with in this chapter. And that would be our 45-45-90 and our 30-60-90 triangles. So hopefully you remember from geometry that the ratio of the sides of a 45-45-90, if these are both 1, then this is the square root of 2. Or we could just say x, and x root 2. On a 30-60-90 triangle, if we make the short leg 1, the hypotenuse is always twice the short leg, and the long leg is always the short leg times the square root of 3. Hopefully you remember that. You better learn it if you didn't know. So if I took these two triangles and I wanted to do my 6 trig functions, let's make a chart, one for the 45-degree angle, one for the 30-degree angle, and one for the 60-degree angle. All right, so just sketch yourself a chart. Here I made too many boxes in mine, and I don't feel like fixing it. So let's look at the 30-degree angle first of all. That would be this one right here. So if I'm looking at the 30-degree angle, then I'm going to go ahead and put a little a here for my adjacent, o here for my opposite, and h here for my hypotenuse. So it helps me a lot. I don't know if it'll help you, but, it might. So we know sine SOH, so it's OH 1 over 2. Cosine AH root 3 over 2. And tangent O over A 1 over the square root of 3. Now be careful because 1 over the square root of 3 is improper, so we multiply the top and the bottom by the square root of 3 to make sure that we get square root of 3 over 3. All right, the cosecant of theta is just going to be the reciprocal of sine, so 2 over 1 is 2. Secant is the reciprocal of cosine, so we have 2 over root 3. Once again, we need to make that multiply the top and bottom by root 3, and we have 2 root 3 over 3. And cotangent is the reciprocal of tangent, which, if you look back to where we started, would be the reciprocal of 1 over root 3, which would just be the square root of 3. All right, so now 60 degrees. We're going to switch it to this angle, which means that our opposite is now our adjacent, and our adjacent is now our opposite, but the hypotenuse is still the hypotenuse. So now, sine of 60, O over H, is going to be root 3 over 2. Okay, and cosine of 60, CAH, is going to be 1 over 2. Notice how these guys just changed places right here? Because we just switched to the other angle, and so we switched to our opposite and our adjacent. The tangent, O over A, is going to now be the square root of 3 over 1. Cosecant then will be the reciprocal of sine, and we already talked about the reciprocal of 2 over root 3 is 2 root 3 over 3. Secant is the reciprocal of cosine. The reciprocal of 1/2 is 2. Once again, notice these are just opposite of each other. And then cotangent is the reciprocal of tangent, and the reciprocal of the square root of 3 is going to be, remember we already talked about that, root 3 over 3. And if you notice, the tangent and the cotangent switch places. All right, now our 45-degree triangle. It doesn't matter which one you choose because they're all the same. So our opposite and our adjacent will both be 1s, and our hypotenuse will be the square root of 2. So SOH, 1 over the square root of 2. Remember, you got to fix it. So multiply the top and bottom by the square root of 2, and we have root 2 over 2. cosine of 45 degrees is a over h, which is also 1 over root 2, so which is also root 2 over 2. The tangent of 45, TOA, 1 over 1 is just 1. Cosecant is going to be the reciprocal of root 2 over 2, which is just the square root of 2. Secant will also be the square root of 2. And cotangent is the reciprocal of 1, which is 1. So make sure this chart's in your notes because we're going to refer back to this later when we start doing our unit circle. All right, so here's a quick example. Here's a 45, 45, 90 triangle. Sorry, I didn't put my 90. And I just want you to solve for x. So now you only have one side. You can't do the Pythagorean theorem, but you can say, well, I know that sine of 45 is equal to root 2 over 2. And so if I know that sine of 45 is root 2 over 2, and it's also O over H, I can plug in the hypotenuse that I have, and the opposite is x, and the hypotenuse is 6. And I can use the ratio that I already know that it equals to cross multiply. 6 root 2 equals 2x. Divide both sides by 2. 3 root 2 equals x. I could do it that way. All right, now let's talk about solving a triangle. What does it mean when I say solve the right triangle? And it means to find all of the sides and all of the angles. So here you go. Here's a right triangle, and all I've given you is one side of 15 and one angle of 28. So we're calling this triangle ABC. We're going to let theta be the angle that we know. That means our opposite is BC and our adjacent is the AC and our hypotenuse is AB. So if we want to find everything, I'm just going to find, okay, what is the measure of angle A? Well, I know it is 28 degrees. What is the measure of angle B? I don't know. And the measure of angle C is 90 degrees. So you got to use your knowledge that the sum of the angles of a triangle is 180, and just take 90 and 28 away from 180, and you get 62 degrees. And so now we know all three angles. To get the sides, we know that side, well here, we want AB and BC and CA, or AC, either way. And all we know right now is AC is 15. So we're going to have to use trigonometry because the Pythagorean theorem is not going to help us here. So we could use any sine, cosine, tangent, or any of their reciprocals. It's all going to give us the same thing. So let's just pick something. If I'm looking for AB, I'm looking for the hypotenuse, and I have the adjacent. So that would be H and A, or A and H. That would be cosine. So I'm going to say, well, cosine 28 equals my adjacent over my hypotenuse, 28 degrees. Make sure you put your symbol. So I can use that to say, well, then the hypotenuse has to be 15 divided by cosine of 28 degrees. And that's something you could put in your calculator. Just make sure you're in degree mode. And you would get approximately 17. Our hypotenuse is AB, so that goes here, 17. And then you can use your Pythagorean theorem, or you can use another trig function. So let's just, since this is a trig lesson, look at, okay, now if I wanted BC, I have the opposite. I'm going to use the adjacent because I know it for sure. O and A is tangent. So tangent 28 equals my opposite, which is BC, over my adjacent, which is 15. Now the 15's in the bottom, all I have to do is multiply. BC is 15 times tangent 28 degrees. Put that in your calculator, and you'll get approximately 8. Or if you were to do the Pythagorean theorem, you'd get approximately 8, either way. So now we've solved the triangle because we've given every side and every angle. All right, so here you are at home. Don't you love your little house? And for some reason, you want to know the height of your bedroom window, but your bedroom window is on the 2nd floor, and you can't climb that high. You don't have a tape measure, but you do have a protractor. So, I don't know, maybe your dad doesn't keep a tape measure in the garage, he just keeps a protractor. And so that's what you've got. You go out there and you found a 25-foot ladder. It says on the thing, 25-foot ladder. So you lean the ladder against your house, and we know that this is exactly 25 feet. We're assuming that your house is going to be built at right angles to the ground, and that maybe that the ground is not on a slope, so, don't do this on a hill. Ladder, sorry. And so you could just create a right triangle, and you could figure out the height of your window. You don't have a tape measure, so you can't measure this bottom part and do Pythagorean theorem. But you take that little protractor, you go over here, bell, sorry, and you measure that to be 31 degrees. So now that we know one angle and one side, we're looking for this opposite side. So we're going to use sine of 31 degrees equals the opposite side over the hypotenuse. So now all I have to do is do 25 times sine 31, and luckily we have our graphing calculator with us. And we will get about 12.876 feet. So these have useful applications in life. And I am done, and I'm going to bow out, and hopefully you guys didn't hate my videos too much this year. Have a wonderful summer, and since the bell rang, I gotta go. Bye.